The third photo on the screen is what I like to think of when I think of a neuron. It looks a whole lot like a tree. I love to relate things back to nature because neurology is confusing. It is highly complex, but when we return to simplicity, it allows us to understand our body in a basic kind of fundamental way because we are natural beings at the end of the day. That black and white photo at the end is what I like to think about when I think about my neurons. It looks like a tree in the forest. There are branches up at the top and there are roots down at the bottom. So if you think about a neuron like a tree, this is a way that I love to think of it. In a healthy forest, we have to have healthy trees. They are the foundation of a healthy forest. We have to have strong trunks and we have to have healthy branches with lots of leaves. It has to be able to absorb the sunlight and process it for the tree. It also has to have a healthy root system to absorb water and again, process that for the rest of the tree. If any part of that tree is unhealthy, the entire tree is going to struggle. When one tree falls down in the forest, it might not affect the entire forest. But if trees all fall down at the same time, there is going to be a tangle in that forest. If you have ever walked through the forest or hiked in the forest and seen a blowdown area, you have noticed that one area of the forest, for whatever reason, maybe unhealthy soil or maybe a really big storm, there is a huge collection of trees that have all blown down at the same time. It causes a lot of damage to the forest floor. Animals can't pass through anymore because the forest is tangled. It is difficult to navigate the forest for anyone when that happens. This is what happens in an unhealthy brain. When there is ama in the brain, when it goes from the digestive system out into the brain channels, it causes this affected neuron forest. The branches of neurons, so each little neuron has all those little branches at the top. The branches of healthy nerve cells and neurons connect at 100 trillion points in our brain. 100 trillion. That is crazy to think about. That is like 100 trillion branches of a forest all interacting. Those trees need to have amount of space between them to be healthy, but they rely on each other. What tends to happen when we have ama buildup in our body and when it travels to the brain is what we see in a blowdown area in a forest. Tangles of neurons happen. And that's what that first photo on the screen is. This is what we see in dementia and Alzheimer's. What happens to those healthy neurons is that they get clogged, they get damaged. And when things are damaged, they don't work anymore. Those branches of leaves that get the sunlight and transfer nutrients into the rest of the tree get damaged. They can't send and receive signals anymore. And what we've learned so far about ama is that it's a heavy, toxic, sludgy substance. So not only do those branches retract, they get stuck to each other and they form into these tangles and bundles in our brain. You might have heard the term neuroplasticity. And this is when we start to exercise the brain, essentially, and we take those tangles of neurons and we start to activate them. And it has been proven in studies that we can reactivate our neurons if they become damaged, but it's challenging. To get a tree to be healthy again is a huge amount of work, and it might not work for some trees. That tree might die. What is super vital for health longevity is that we prevent ama from reaching the brain. Prevention is so much easier than trying to chase our tail, so to speak, and to fix problems that have already set in. When we talk about neurotransmitters, these are the substances that flow between neurons. So again, this is not meant to be a neurology lesson, but some of the neurotransmitters that we might be familiar with are serotonin, dopamine, and oxytocin are kind of those feel-good neurotransmitters. So what happens with a lot of mental health diseases in particular is that there are those tangles and those bundles and that stickiness of AMA in the brain. So those feel-good feelings can't flow anymore. They're stuck. Instead of those branches being healthy, they're all tangled together, and those feel-good feelings can't flow anymore. Again, AMA is heavy and sticky and stagnant. It is the opposite of those feel-good emotions. An analogy that I like to use is a charging cord. And this is kind of like a neuron. There's one end and there's the other end. This one we plug into the wall and it gives us power. This side we plug into our phone and it charges our phone. We need both of those ends to be healthy and working, much like we need the top of our axons, or the top of our neurons, I should say, and the bottom of our neurons to be healthy in order for that neuron to work properly. If someone bent the end of one side of a charging cord, we know that that's not going to charge our phone anymore. We also need the axon of the neuron to be healthy. So the trunk of our neuron needs to be healthy. We've probably all had a phone cord that gets completely busted at some point, and that axon sheath, or the myelin sheath it's called in a neuron, gets destroyed. So this cord has the axon damage. The trunk of this cord has been damaged. Technically, this still charges my phone, but I know eventually this is not going to work anymore. And it's kind of risky business charging my phone with this. It is not healthy, it is not whole, and it could cause damage down the road. We need to keep our dendrites and our axon terminals healthy, and we also need to keep the myelin sheath coating our neurons healthy. So in our one-on-one sessions, if this is something that you are interested in learning more about, we can definitely talk about this. Again, this is not meant to be a neurological lesson, so I hope that wasn't overwhelming for anyone. We are going to discuss more about how to keep all parts of our charging cord, our tree trunks, our branches, and our neurons healthy in the upcoming slides.